Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, motion in straight line. Under that, uniform motion. Under uniform motion, we will be discussing relative velocity. I will explain that topic and then derive the formula for calculating relative velocity. I have also included the graphical representation of two objects moving in the same direction with uniform velocity. Please watch the video completely without skipping so that you get all points cleared. And if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you are watching without subscribing my channel, do subscribe my channel now and support me. Also press the bell button and all button for notification of more videos like this. I have given a few questions as usual. Thank you very much. Come, let us see the class right away. We will discuss relative velocity in one dimension. I will explain this term first and then pass on to derivation. When do we use this term relative velocity? I will explain that. Imagine two objects A and B are moving along parallel straight lines in the same direction with uniform velocity VA and VB respectively. Now we want to refer to the velocity of one object, say velocity of object B with reference to or as compared to the velocity of object A. Then we use the term relative velocity. So this term is used to refer to velocity of one object as compared to or with reference to that of another object. There is an easy formula to calculate relative velocity. In the case of object A and B, the relative velocity of B with reference to A is given by the formula VBA is equal to VB minus VA, where VB and VA are their velocities. Velocity is a vector. On the other hand, suppose we want to refer to velocity of A with reference to B, that is velocity AB. Then the formula becomes velocity AB is equal to velocity A minus velocity B. But actually, we have to derive this expression. That is the topic. But before we pass on to derivation, I will just explain the significance or use or the benefit of learning this relative velocity topic. I will explain this with the help of a small illustration. We will consider two cars, an yellow one and a blue one. Since we are considering the motion of cars, it is logical to use the unit of distance in kilometer and unit of velocity in so many kilometers per hour. But here I have used meter and meter per second as the units respectively. This is just for easiness, and moreover, when we come to derivation, these quantities and units do not have any significance. Okay? Let the blue car be the object B and it is traveling with uniform velocity VB, and yellow car is object A moving with uniform velocity VB is not equal to VA. In order to help you understand better, let us consider VB is equal to 2 meter per second and VA is equal to 4 meter per second. So here VB is less than VA. At time T0, that is initial time, object A is at 10 meters from origin and object B is at 14 meters from origin. What do you understand from this? We understand that B is 4 meters ahead of object A, but the velocity of object A is greater than the velocity of object B. So, what is their relative velocity? What is the relative velocity of B with reference to that of A? That is, what is VBA? That is, if you consider its position after the first second, the object A, that is the yellow car, will be at 14 meters and object B will be at 16 meters from origin. This is for the first second. During the second, the object B will move 2 meters ahead. That is, it will be at 18 meters, whereas object A will move 4 meters and it will also be at 18 meters. So, at the second, they will meet each other. They will be at the same position. During the next second, that is the third second, the yellow car overtakes blue car, travels 4 meters further forward, whereas the blue car can move only 2 meters per second because of the difference in their velocity. Object B will be at 20 meters and the object A will be at 22 meters from the origin. After the second, they will never meet again during their journey. I already gave you the formula for calculating VBA. It is VB minus VA. So the relative velocity of B with reference to A is 4 meter per second minus 2 meter per second, which is equal to 2 meter per second. You get a positive value. So B is moving faster than A. On the other hand, relative velocity VAB, that is velocity of A with reference to B, will be 2 meter per second minus 4 meter per second, which will be negative 2 meter per second. That means A is traveling at a lower speed when compared to that of B. Now that you have understood relative velocity, we will pass on to derivation of this equation. We have to follow a few steps. Velocity of A is VA, velocity of B is VB. Initial position of A is x naught A. This is at time t naught. Initial position of B is x naught B, also at t naught. So they are not at the same location. There is a difference in their position. Change in position of B with reference to A at t naught, that is initial time, is equal to x naught, and that is equal to x naught B minus x naught A. We want to find out the change in the initial position of B with reference to that of A. Therefore, we write the initial position of B first and then initial position of A. X naught is the initial change in position. It becomes equal to x naught B minus x naught A. Velocity is change in position divided by time. What will be relative velocity? It will be relative change in position divided by time. In order to find out the relative change in position with a reference to time, we first consider a certain time, say t. After t seconds, what will be the position of object B and object A? That is, what is its displacement during t seconds? We already know that displacement is equal to velocity into time. We can consider the time as 10 seconds, 20 seconds, 30 seconds, or a few hours. Doesn't matter. But for the present, we will consider that time as t. That is, here we have taken the unit as second. So, t seconds. So, position of A after t seconds, let us take it as xa, will be equal to x naught A, that is the initial position, plus velocity of A, that is VA, into time t. xa is the position of A at time t, x naught A is the initial position, VA multiplied by t is its displacement during time t seconds. Similarly, position of B at time t from origin equal to xb is equal to x naught B, that is initial position, plus VB multiplied by t, that is its velocity, into time. Now that we know their position at time t, we can easily calculate the change in position after time t. Change in position of B with reference to A at t is equal to x. We take that symbol. That is equal to xb minus xa. And we already have a formula for xb and xa. So we simply substitute that. So xb is x naught b plus vb multiplied by t minus xa is x naught a plus va multiplied by t. This can be further written as change in position of B with reference to A at T equal to X is equal to X naught B minus X naught A plus VB minus VA multiplied by T. We know X naught B minus X naught A is equal to X naught. That is the change in position of B with reference to A at initial time T naught. So substituting, we get x is equal to x naught plus Vb minus Va multiplied by t. When we rearrange the quantities, x minus x naught divided by t is equal to Vba, relative velocity. That is, relative change in position divided by time gives relative velocity. Relative velocity of B a is equal to Vb minus Va. So we have derived this equation. Change in position of the objects at time t minus change in position of the objects at time t naught divided by time taken is equal to Vb minus Va. I have repeated this equation so that you understand what is x and x naught. We will also see the graphical representation of position time, velocity time, and acceleration time graphs. In this case, the position time graph shows object A at 10 meter and object B at 14 meter at initial time. And after the second, it is at 18 meter and they meet there. Velocity of A is greater than velocity of B. The slope of A is greater than the slope of B. Now, refer velocity time graph. A moves with uniform velocity of 4 meter per second. B moves with a uniform velocity of 2 meter per second. You can see the two graphs are parallel to the time axis. The position time graph is inclined to time axis. The slope of position time graph gives velocity and the slope of velocity time graph gives acceleration. For uniform velocity, the slope will be 0. Therefore, acceleration is 0. Area under velocity time graph is equal to displacement. Now let us see acceleration time graph. Both the objects are not accelerated because they are moving with uniform velocity. So their acceleration time graph will be on the x-axis, that is on the time axis. So I have shown it here separately because both lines cannot be shown together on the x-axis. Okay. If you find the video useful, do like the video and share the video with your friends who may also be benefited, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and also press the bell button and all button for notification of more videos like this. Thank you very much for your support. We will meet in the next video with another important topic like this. Till then, bye. Take care.